In this lecture, we're going to learn about const member functions. And this is a solution to the problems that we have been experiencing with const objects in the last two lectures. Let's look at this. We have our dog class, and it's really what we have been using all along. We have a few constructors, and we have our setters, we have our getters, and we have a few member variables inside that we are trying to manipulate through all these functions here. But the problem is, if we try to use a const object and try to do things with it, we're going to have serious problems. We have seen that in many cases, we want to be able to read from a const object because the compiler thinks that our getters are potentially going to modify the const object. The compiler is going to try and protect the constness of the object, and it won't allow us to read from the object. And from this perspective, these objects are really going to be useless because we can't do things with them. So let's make our goals clear here. If we set up a class, we want to be able to use it. For example, if we have a const object, we want to be able to, for example, read information from it. The printf function should work. But the setters that are going to try and modify the object shouldn't work with our setter here because this is going to be modifying the member variables of the object. But if we don't have a const object like dog2 here, we should be able to modify it and we should be able to read from it. This is what we expect from our objects here. So the problem is going to come with const object, and we need to tell the compiler that some functions are never going to be modifying the object. And we can do this through marking our member functions as const member functions. So let's see how we can do that. For example, here we have our getters, and we tell the compiler that they are constant member functions by appending a const after the parameter list. So our get name is const because of this const here. Our get breed function is const because of this const here. Our get age function is going to be const because of this const here. So if we flag our member function as const, the compiler is going to know that this function is never going to modify the object. And if you try to do any modification from this function, you're going to get a compiler error. The benefit is that this function is now going to work on const object because you will have told the compiler that this function is never going to modify our object. And this is really cool. Our objects are now going to be usable even if they are const. If you happen to be splitting your function into declaration and definition and defining your functions on the outside, this is also going to work. You will need to add the const after your parameter list like you see here. Another thing I want you to know before we head over to Visual Studio Code and play with us is that you can overload your functions based on whether a member function is const or not. For example, here we have two functions. One is const, the other is not const. So from the const function, if we try to modify anything about our class, we're going to get a compiler error. But the non-const function is going to be able to modify this without a problem. So you should know that it is possible to overload your member functions based on whether one is const and the other is not const. And you can see that right here. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is const member functions, which is what we want to explore. And we're going to use the last project as a starting point. We're going to grab our dog object. And I think we should even grab the main function and the VS Code folder, which is going to contain our settings. We can grab everything. And we're going to use that as a starting point in this project here. We can do that. So we're going to open this in Visual Studio Code by dragging and dropping here. This is going to open our folder and we can open all our files. And let's open dog.h here. We can close the left sidebar here. And we want to tell the compiler that some functions are not going to be modifying our object. And we're going to do that by flagging them as const member functions. So the functions that are not going to modify our class are the getters and the utility printinfo function here. So let's do that. We're going to add a const after the function declaration here, and this is going to flag our functions as const. And we're going to go down and flag printful as const because we don't really intend to change our objects through these functions here. They are just meant to read information from class objects. Let's go in the implementation file and change our functions to also be const member functions. You notice that we have a few squiggly lines because what we have in the implementation file at this moment doesn't really go in line with what we have in the header file, but we're going to fix this in a minute. We're going to flag our getName function as const. The getBreed function is going to be const. The getAge function is going to be const. A const member function, I mean. And the printful function is also going to be const. So let's add a const here. And what this is going to say is saying these const member functions are never going to modify the object in any way. If we try to modify the object in these functions, we're going to get a compiler error. So suppose we are in the getName function and, for example, we want to set the age. Let's try and do that and see what we get. Let's say mh equals 6. If we do this, we're going to get a squiggly line because we can't really modify this object from a const member function. The compiler is going to make sure of that, and it's going to guard against any modification to the object from these functions here. Okay, so now that our getters and utility function here are const, we can go in main and try to see what's going to happen. Here we have our main function and everything we tried to do from the last lecture. We're going to have our const object here. I think we can comment this out because it's going to be ugly in our code. We have our dog object, which is const. If we try to read from it, we're going to see that it's going to work now. Let's say dog1 printful. Okay, so this is not going to modify the object. You see that we don't have any squiggly line. The compiler is going to know printful is now a const member function. It's not going to modify the object. I am going to trust it, and I'm going to let you call this function on your const object. This is the message here. So let's try and build and see that this is actually going to work. Okay, the build is good. We can bring up a terminal and run rooster. We're going to clear first and run rooster. You're going to see that we are printing information about our object here, which is const. And this is really cool. Const member functions are going to be allowing you to use many of your member functions on const objects. Okay, so this is not going to change anything if we call our function, which is going to take parameters by value. It is going to work, but what we can do now is print the address directly from the printful function without directly printing the address like this. Printful here is going to work. It's going to show that we have an outside address, and a function taking dog is going to do its thing. It's going to set the name. It's going to say printful, but we're going to see that the address we see on the inside is different from the address we see from the outside here, because on the inside of the function, we're going to be working on a copy. And this is really cool. So we can build the program. The build is going to be good. We can clear and run rooster. We're going to see that the address we have on the outside ends in DA0. The name is going to be Fluffy. The breed is going to be Shepherd. The age is going to be 2. But on the inside, the address is going to change to another address. So this is a copy we are working on from the body of our function, which takes the parameter by value. Okay, so this is something you should know, and we are able to change it without a problem because the changes from the inside are not going to be affecting the outside const object here. So we can comment this out and see if we can pass by reference here. Let's uncomment this. And this function is going to take by non-const reference. And the compiler is going to protect us from doing this because this reference could be used to modify our const object. And we don't want to be able to modify it. That's why the compiler is going to stop us from doing this here. And this is really good. We are protecting the constness of our object. But if we pass by const reference, the compiler is going to let this work. Let's go back and look at this. The compiler is going to let this work if we're not doing anything in here. and we're going to be prevented from changing the object. We don't want to change the object through a const reference. The compiler is going to protect from this. But because we have a const object and we have const member functions inside, this is no longer going to be an error. We will be able to read from the const object because the printful function is a const member function now. So the call here is going to work if we don't try and modify our object from the inside. And we are passing by reference, so the address from the inside is going to be the same as the address on the outside. So let's clear and build this. I don't think we have built this, so let's pass this through GCC. You're going to see that the build is going to be good, and if we call our function that takes the parameter by const reference, you're going to see that the address on the outside is going to be the same as the address on the inside, and this is really cool. If we pass by non-pointer, we're going to have the same problems. The compiler is going to prevent us from doing this because the pointer could basically be used to modify our object here. The compiler won't allow to pass our const object as a parameter to this function here. And hopefully you understand why. Because we could go through this pointer and modify our object. But if we pass by pointer to const, the compiler is going to trust this pointer. If we try to modify through this pointer, we're going to get a compiler error because this is a pointer to const. We can't go through it to modify our object, and we expect to get this error. The compiler is going to enforce for this pointer not to be used to modify our object in any way. So our setter is not going to work. But if we try to call innocent functions, which are not going to modify our object in any way, for example, the printful function, which is innocent because it is a const member function. Again, if you go there, you're going to see that it has the const qualifier after it. So it's never going to modify our object here. This is no longer going to be an error because the compiler trusts this function now. If we go down and compile this program, we're going to do that. You're going to see that the build is going to be good. And if we run, we're going to see that the addresses from the outside and the inside are the same because we are passing by pointer to const. What we point to from the inside of the function is going to be the same thing as on the outside. It's basically going to be this dog object here, which is const. And this is really all I wanted you to see in this lecture, that if you want to really work with const objects, you have to go in and make sure which functions will never modify the object and mark them as const, and functions that are going to modify the object are going to be left as is. And basically the compiler is going to think these setters are going to be modifying our object, and the getters here, they are const, they're not going to be modifying our object. The utility function here is const, it's not going to be modifying our object in any way, and you can make your code a little safer. Please make sure you use this to your advantage and mark any function as const if you think that this function is never going to modify your object. We are going to stop here in this lecture. In the next one, we're going to show you that you can set up setters that work as getters. I realize this is confusing, but it is possible. So go ahead and finish up here and meet me there.